Who needs some help with their homework? Okay, so I decided that I was going to do a Module 4 review because you guys have questions 1 and then 3 through 17 for homework. I'm skipping 2 because I want to show you some tricks on the calculator to use the fraction buttons that will make your life a little easier. So I'm going to go through some of the main topics we covered in Module 4, okay, that you'll at least need to know for your homework. There's more than this, but you'll see another video coming. So Module 4 review. The first few questions that you have, question 1 for example, and 2, which we'll go over tomorrow, involves order of operations. So how do we remember order of operations? Well, we have the saying PEMDAS, please excuse my dear Aunt Sally. And the key things you need to know from that is that you do parentheses or brackets first, you do exponents next, then you do multiplication or division, whichever you encounter first in the problem, and then next is addition and subtraction. So if we had this question that you see on the right here, this example, like I know in your homework you have a question that has a set of brackets and a set of parentheses, you need to go to the innermost set of parentheses first. So, you know, we're going to do parentheses first. You look within the parentheses. I'm going to circle what I'm talking about here. We're going to kind of zoom into that, right? And we're going to look at this. We see an exponent, we see addition, then we see parentheses. So we need to do parentheses first, okay? So each time you kind of see a set of parentheses, you're hitting the reset button on PEMDAS. So 8 minus 3 is 5. Everything else gets rewritten, okay? So we haven't dealt with everything in those brackets yet, so I need to keep writing them until we take care of everything. Okay, so next step that we need to do is exponents right here, because exponents is before addition. So 4 squared is 16. Right, so you, again, copy everything down. The biggest mistake I see is when kids do more than one step at a time. So we still got to deal with these parentheses. That'd be 21, 3 times 21, plus 5. Now, another thing I want to point out to you guys is that when you have a number up next to parentheses or brackets, that means multiplication. So this would be 63 plus 5, which is 68. All right, so your answer here is 68. When you're done, it should look like a big piece of pizza, right? And any of your work would go on the side, and we like to say that's dipping sauce. So anyway, we're going to go on to the next thing you need to know, which is coefficients, which means multiplication in the math world. So if you were adding, you know, say h was 5, 5 plus 5 plus 5 plus 5, you would have 4 times 5, right? 4 groups of 5. We have 1, 2, 3, 4 groups of h. So another way of writing that is through multiplication. We would write 4h. Nice organization. But 4h is one way of writing that. And again, in algebra, we don't use dots, we don't use x's, we use coefficients when it comes to numbers and variables, so the number just goes straight in front of the variable. All right, so you're going to see that on your homework, that concept. The next thing you're going to see is exponents, and I can't type the dot, so let's say it's n times n times n times n times n. So this is different in that we see repeated multiplication. When you see repeated multiplication, that means we're going to use exponents. So ignore that I just wrote that. All right, what we're going to do is write n. You write your base number, so that's the number that's repeatedly being multiplied. That's your base. And then your exponent is how many times it's being multiplied by itself. So 1, 2, 3, 4, 5 times you're going to put an exponent of 5, which is the little number up in the right hand kind of corner of that. All right, so that's how you write exponents when it comes to algebra. Let's move on to the distributive property. So another thing you're going to see is some parentheses going on and some operations, and you have to distribute the number on the outside times everything on the inside. So this is how I learned it. You just go like this, right? And then you multiply whatever this number in front is times everything on the inside. So that's the same thing as saying 5 times 4 plus 5 times 3. The biggest mistake kids make is they forget to multiply that outside number by, you know, this term at the end. So you don't want to forget that. So that would be the same as saying 20 plus 15, which is 35. Okay? So if you were to do this ahead of time, you'd see 4 plus 3 is 7. 7 times 5 is 35. But anyway, distributive property looks like that with numbers. When we are looking at this with algebra, you know, instead of having just numbers, we're going to have some variables in there too. So we're going to multiply both sets of terms here. So we have 6 times 2b. Well, 6 times 2 is 12, and we still have to multiply it times that b. Plus 6 times 3 is 18. All right, now the question is, can I combine these things? Well, this is 12 b's, and this is just the number 18. You cannot combine those because they are not like terms, so you have to leave that alone, okay? Let's go on and do some more of this. You have lots of questions that involve the distributive property. Combining like terms, oh, actually I want to go back to this. Another way that I recently learned, it's not the way I learned personally how to do this, but I think it's pretty cool, is you kind of set up a box and you put each of the terms in a section. So 2b, actually no, you put these on the outside. So 2b plus 3, and then you put the 6 here, and you multiply 6 times 2b, which is 12b, and then 6 times 3 is 18. So, and then you got to add there, obviously. So 12b plus 18. I don't know if you see that easier. You know, really depends on how your brain's wired, but if that helps you, there you go. Let's talk about combining like terms. So when you have a bunch of variables and stuff going on and you're trying to simplify the expression, you might hear that language, you want to put all the like things in a pile. So for example, if we have 2 of these y's, right, we would have 2 y's. Plus we have a 3. The 3 does not have a y right there, so we cannot combine that, okay? Down here, 5x minus 2x plus 7x. So if we have 5 x's, we take away 2 of the x's, we're going to be left with 3 x's, but then we've got to add 7 more x's. So if you have 3 x's plus 7 more x's, that is 10x, all right? And those all can be combined because they all have this x attached, you can see. Now what happens though if we had 5x minus 2x squared? Can those be combined? The answer to that is no, because this one, you can see right here, this term has an exponent. So you can only add or subtract these numbers when they have the same exact variable, okay? And when I say combine like terms, that means add or subtract. You can multiply anything, but when it comes to adding and subtracting, we don't know what x is worth. So we can't combine that with a y, for example, because a y and an x aren't the same thing. All right, a question you have on your homework looks like similar to this. It gives you 2 numbers plus a blank equals a certain quantity, and you've got to figure out the missing piece, all right? So this includes the skill of combining like terms. So 3x plus x. So if you want to see a visual of this, so this is 3x maybe plus an x. And again, we don't know what the value of this is. We just know that there's boxes with an unknown number in it, right? Equals 10x. So this is going to be fun. All right, I'm going to do this. Right? If we need all of this to pile up to 10 x's, just to kind of give you a visual here, right? So we've already got 1, 2, 3, 4 of those. 1, 2, 3, 4. 1, 2, 3, 4. We still need all of these, right? We need 1, 2, 3, 4, 5, 6, right? Because we know we need 6 x's, I should say. Because 3x plus x, we have 4 x's, plus another set of x's is going to give us 10 x's altogether. So it'd have to be 6x, okay? Let's move on. Perimeter, so they kind of take this skill to the next level and apply it to geometry. And perimeter means the distance around the outside of a shape. So in this case, we have a pentagon. We have x, 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 x. And to find perimeter, we'd want to add all of these sides. Okay, so we have x plus x plus x plus x plus x. We have 5 x's being added, so therefore we would have 5 times x. All right, now again, on your homework, you have a question similar to that, except for they've got some situations where, you know, they have an x and a y. So what do you do then? Well, again, you're adding all of the sides. You're adding this side, you're adding the bottom, you're adding the right side, and you're adding the top. So when you do that, you're going to get x plus y plus y plus x plus 5. All right, so let's combine all of our x's. You notice we have 2 x's, right? We have an x here, we have an x here. So that's 2 x's plus, we have 2 y's right there. Right, you can see them up here too. And then we have 5, just plain old 5. All right, and we cannot take this any further because, again, you can only combine them if they have the same variable attached. And in this case, x is not the same as y, so we cannot combine those. All right, let's move on to the next one. You're asked to write some expressions at the end of your assignment, and just to review some of the words that you need to have a knowledge of are words that indicate subtraction. So difference is the answer to a subtraction problem. Less than is what we call a flip-flopper. So if we have something that says n less than 7, that means even though the n is listed first and the 7 is listed last, that means you start with 7 and you subtract n from it, right? If I had $2 less than Joe, that would mean whatever Joe's amount, you'd subtract 2 from to get my amount, right? In this case, we don't know how much less, but it's a certain amount less than 7. So we got to start with 7. With the other ones, if we said the difference between n and 7, difference between, that would be n minus 7 in that case, right? So when you have a flip-flop, you got to kind of think about how that's listed. Other words where it's kind of just straightforward would be subtract and minus. Let's go on to multiplication words. Did I talk about addition words? Did this thing skip? Okay. Addition expressions, more than, sum, add, plus. You know, you kind of see these with all types of problems, but, you know, probably more commonly maybe with addition. So addition, subtraction, pretty straightforward. When you have multiplication, a key word, you know, would be of. A lot of people don't understand that when you have like half of something, it means you're multiplying it by 1/2. Like product you see all the time, obviously times. Double and twice means multiply something by 2, right? And triple means by 3, quadruple means by 4. If we go to the next section, we have division. Quotient is the answer to a division problem. Obviously, you'd see divide. Another kind of tricky way of wording this is if you had 10 bananas shared equally amongst n kids, right? It would be 10 divided by n, or 10 over n, written as a fraction. Split equally is another way of saying that. And then you also have things like half of. I said of means multiplication, but if you're multiplying something by 1/2, if we have half of n, right, that's the same thing as saying n divided by 2. So you may run into that as well. And actually that is it. I just wanted to review this, all the concepts that you'll see in your homework tonight, because I'm sure a few of you have gotten home and are struggling a little bit. So hopefully that helps. I'll see you tomorrow. Bye.